G'day, Michael here. Sorry I haven't been around for a little while. I've been a bit busy. I've been building it's kind of an attic structure above my office in the workshop. Yeah, I'm trying to make it a fairly dust-proof, sealed area. I'll give you a quick squiz around, not that I think you can see very much. Pretty confined space. Anyhow, you can see I've got a bit of a lab arrangement here. You can see I'm already starting to set up two of the prison style printers here, the Black Widow and my little G-Tech i3. But in the process of setting up what I'm setting up, I'm moving towards having an OctoPi set up, and that gives basically a web interface to control your printers from. Because this is up in an attic type arrangement, I want to be able to see what the printers are up to without having to climb up the ladder every 5 minutes to see what's going on. And I've already done one of these units. I'm in the process of doing basically the whole set of 5. I have 5 printers, so 5 OctoPi rigs. Maybe you can do it more efficiently, but that's what I'm going to be doing anyway.
Okay, so what is it that the OctoPi rig can do? Well, it's OctoPrint's printer management setup on a Raspberry Pi. As you can see on the left screen, I'm looking at Prusa.local. I've called that unit Prusa, and this is showing you the temperature and how the temperature has risen to what it's supposed to for the bed and for the hot end. Here we can see a video. I've just basically opened this other tab in another window and put them side by side so you can see them both in operation. You can see it's doing a print right now, running around in circles doing its thing. But the system allows me to, well, allows the user, any user, the ability to look at what's going on with the printer remotely. And for me in my little attic up here, my little lab, it's going to be a big plus. As I'm only just setting this up, I haven't got a long history of it, but I've certainly already done enough to know that I want all 5 units set up, and I'm quite impressed with how it all operates. So that little Raspberry Pi running the OctoPrint software is doing this job for us. Now I've set up another one which I'll show you how I actually go about setting up this unit. This one's for my Delta. I don't have any camera on it and so forth yet, but here you can see Delta.local. We can look at temperature. It's not actually talking to the printer, so it's got nothing to show us at this moment. But here you can see the one active one that I have is the Prusa. You can see the camera, the temperature. You can also see a flow of the commands to and from the unit. And also you can manage time lapses. Now I'll show that later on. But anyhow, that's what the OctoPrint system lets us do, and probably a heap more than that. But let's go into actually how we do it.
Anyhow, they're quite a cheap thing. It's sort of sub $50 in Australia here. And they come with quite a few accessories. And this one here is the Raspberry Pi 3. And I've chosen this because it seems to be one of the top performers for this job, and everyone seems to recommend them, so I basically went with that. Safe, available, and as I've tested, it's actually quite easy to get up and running. Okay, so the computer side of it, we have to prepare the operating system. Now the operating system goes into this little micro SD card. Okay, so you can see it's a micro SD. Now the operating system has to be put on to this little guy, and back out again. So for that you'll need a PC with a card reader that'll read the micro SDs, and you need to download basically it's a disk image. If you're not used to dealing with disk images, they are akin to a physical piece of hardware as a file. They're not like most people are used to using the file system, which is the hardware has been set up with a way of organizing the data. Well, this image is actually not a space to put files on. It is actually an echo of the hardware. So it's sort of all the ones and zeros that make up a physical drive storage space. Now, I've seen on another YouTube tutorial video, and that's part of one of the things I want to correct for those that are trying to set up their own Raspberry Pi setup. When you do an image, it doesn't matter what the file system that exists on the microSD actually has on it, because you're actually wiping the hardware. So any partitions, any formatting, it's all gone. It's got nothing to do with the files you're copying, because the files are in fact a disk being put there, not files sprinkled over a file system. When you copy photos onto an SD card, you're using the existing file system, which is usually a FAT32 file system on SD cards, and I think it's exFAT if you're using like 128 gigabyte unit. I'm not sure whether the Raspberry is designed for exFAT, but in any case, FAT32 is a common file system on SD cards, but we're not using that. We're using whatever it is that the Raspberry operating system, which is based on Debian Linux, is using. And we can look at that later. I haven't actually looked up what sort of file system that is. I'll have a look at that in a minute. But you don't have to worry about however the SD card is formatted, because you will be replacing it at absolutely ones and zeros level. It's not like copying files onto an SD card. Okay, so you don't have to worry about what's on it, except it's all going to be gone when you've done the image copy. So on Windows, I believe you have to download and install a image creator of sorts, or image copying device. On Linux, you use DD. It's real low level. It's equivalent to something like Norton's Ghost, but it's an absolute ones and zeros copy, disregarding what arrangement there is on the file system. So DD is an absolute copy. Danger with using DD is you have to be on as administrator to get access to your hardware, because it has to work actually on the hardware. So you have to pay attention with what you're doing if you're using a Linux system. I suspect you have to do that anyway with a Windows system, or Mac or whatever's going. I'll say that again. There's good information on the OctoPrint website, which actually references back to the Raspberry Pi website, on how to set up the OctoPi. So you're using OctoPrint on a Raspberry Pi, so OctoPi. Yeah. Anyway, let's move on to that.
Okay, so what I'm going to do now, I'm using Ubuntu Mate Linux, and I'll just plug in my USB card reader. And it's come up. Now, there's nothing on the disk. Let's just have a look with the disk's utility. Where are we now? Should be here somewhere. There we go. Okay, so there's the 16 gigabyte drive. It's come up as device SDG, and the first partition is SDG1, and you can see it's FAT32. So that's a common file system for a SD card. As I was saying before, the file system's irrelevant, so it doesn't matter what it's formatted as. When we do the image copy, it will be transferred as ones and zeros. Now, if we go to, let's just change screens. If we go to the website, OctoPrint website, it's probably the easiest way to get hold of it. It's just type in OctoPrint. Actually, OctoPi might be even better. OctoPi. Okay, so you can see there's an early listing straight up there. Okay, so this is how you download. You can buy all-in-one printers, print kits, which is basically the Raspberry Pi and camera and all that sort of bits, and all the bits and bobs together. But in any case, you can download the OctoPi image. So let's do that. Okay, now I'll get it to save. Now I've downloaded this previously, and there was an error in the file. So I'm hoping this comes correctly. See how this is going any time now. That'll take the time that it does. Okay, so let's have a look at the SD card. I'll change screens back again. Okay, so the SD card has got nothing on it. Now, with Linux, use a dd command. Now, I'll just open a, actually I'll open a couple of terminals. Now, to find out, we've got this graphical user interface called disks on Ubuntu Mate, but regardless of what system you're using, with Linux you can use command line. So I'm typing in lsblk, which means list block devices. And as you can see in the listing, we have SDG and the partition SDG1, which is mounted at media Michael transfer, Michael being where my files, it's assigned to my user. So there's, you can see in the graphical environment, the equivalent to this command line environment. Now, getting to know the command line tools is actually a big advantage because Raspberry itself is using a Debian-based Linux distribution, and Ubuntu is also a Debian-based system. So getting to know your way around the command line is a plus. It's not essential, but it's helpful. In any case, when you use the command line tools on Linux seriously, you still only get to learn a few commands. You don't actually have to learn that much. But funny enough, the commands are always there. Whereas if you use a graphical environment, you have to go looking for the icons and so forth. So don't be intimidated by a command line interface. It's actually a lot easier and quicker than the graphical. And some people are intimidated by that and they think it's somehow retrograde, but it's actually, I use both. Where the graphics is the fastest, best, most intelligent and most productive way of using it, and most reliable, I use the graphics. And the graphical environment on Linux is no different really from any other system. In fact, there's a lot of tweaks and things that it has that other systems don't have. For argument's sake, I've got this multiple desktop here down the bottom here. So if I click on, you can see there's a number of desktops showing there that maybe just see a clutter of rectangles. That highlighted one there, you can see this is a rough facsimile of the screen you're looking at. If I click on the next one where you can see the Firefox icon, you'll see the whole screen is Firefox. The next one's blank, so there's nothing on that one. All right, so it's typical desktop. So for argument's sake, we could launch VeriCAD. Okay, so VeriCAD's the 3D CAD modeling program that I use. Every system's got its optimizations, but VeriCAD works for me. Okay, back to Firefox. Has it finished the download? Yes, it has. Okay, so if we go back to the other desktop, as you can see, we can leave desktop set up however we like. Okay, so we're back on this other desktop, and as I was saying, the graphical environment on Linux has actually got some further features than Windows or Mac has. There is one thing that I find that I would prefer to be improved on Linux. It's the only thing really that will impact us here today, and that is on Windows, when you're transferring files to an SD card, it reports more directly what's happening on the SD card, whereas on Linux it tends to report as soon as something's copied across, as far as caching is concerned. And if the hardware is really slow, the hardware will eventually catch up to what the computer's done. So in one sense it's quick and productive, but with an SD card, because you're likely to remove it, it's not reporting the actual transfer speed as well as I'd like it to. Funny enough, it works perfectly with Compact Flash, but Compact Flash generally runs faster. Okay, now the other thing that we're going to have with DD, being a very, very low level program, I'll click back into this opening, this terminal. Being a low level program, it doesn't really have a good progress indicator either, but it does report accurately when the job is done. So the DD command is actually very solid for when it says it's complete, it is complete, because it does work at the hardware level. Okay, now on Octoprint's website, let's change to desktops again. They show, there's what you download. Scroll down and you get instructions. This video from Tom's video page is pretty good for setting up the Raspberry Pi, but going to the instruction down here, we can go to the Raspbian wiki, Okay, and here they explain a lot of detail that you don't need for what we are doing here. So for Linux or any operating system, so if you're using Windows or Mac, you can click on this link here. Hopefully it'll talk to us any day now. There we go. And on Linux, the unzipping software is already installed. You don't have to go to your way to install it. Okay. Now, of course, I've used Linux, and my instructions here are Linux specific. And here you can see the lsblk command. Right. So this is the dd command which we need to use to copy to our SD card. And what's not really that clear to a new user is what this business is all about. Okay, now I want to copy that to our terminal, so I just copy. Now if you remember, I went lsblk, which is list the block device, and see how it came up as SDG. That's our physical disk. Then we've got a partition SDG1, which is the first partition. Now that's irrelevant to us. All we're interested in is the physical hardware, not the partition. If we were copying photos from our camera, we'd be copying it onto this file system, which is SDG1. But we're replacing that with a whole disk image, so which we're writing it to the physical disk, SDG. Okay, so I'm going to paste in their instruction. I might make this window a little wider. Okay, now what this is all saying, DD, I'm not sure what DD stands for. Let's just actually look that up. Man DD. Okay, and this is the Unix or Linux manual system. Any of the Unices will have this same manual arrangement. DD, simply convert and copy a file, but it's so absolute in the copy that you can copy a disk physically. Alright, so you can read the instructions there if you want to look into this more detail, so you don't have to feel like you're going in blind. If you want to read that, feel well and good. You do not, it is not required. Okay, so DD is the command. BS is block size, not the other BS. And the block size here is 4 megabytes. So that's basically caching 4 megabyte blocks. So it's much quicker to transfer than if we're going like single bytes, because it'll also transfer single bytes if it's told to do that. Now the input file, IF, equals whatever that file was. Now let's just go find that file. It's getting a bit cluttered on this desktop. Let's go to another one. That's my video recording one. Let's go to another desktop. Let's go to that, and you can see there's the transfer, but we're after what our downloads were. So the download is called, now this is the new one. I downloaded it earlier. I'll just click on that. We have to unzip it to extract it. I might get rid of the old one so it gets rid of that confusion. Extra rubbish. Okay. So this is the file that we've just opened in the extractor, or the unzipping arrangement. Extract. Bang. It's a fairly sizable file, so give it a few seconds. I would expect to be done now though, I must say. Done. Okay. Close. Now, that's the file that is extracted, 2018 yada yada, right? So I'm just going to go cheat and go copy. Go back to our other desktop. So our file is actually going to be, is that what it is? Go across. That Q is my left arrow, by the way. Okay, so oops, delete that, paste. I can get rid of the front bit of that. Left arrow again, that is. It's quite interesting to see the, okay, so that's the location of the file. Home, Michael downloads, yada yada yada. Now they've given an SDX as the output file. Output file now, so it's taking this image file as the input file, and it's calling the output file the physical hard disk, or in this case it's an SD card. And we had SDG, right? So SDG is what we're after. So we have to use SDG. Now I'll just confirm that I'm not talking nonsense. So I'll get out of this manual. To get out of the manual, you press Q. Alright, so LSBLK again. Okay, you can see it was device it was SDG. That's the device. Okay, so we've got, looking back at our DD command, DD, block size 4 megabytes. Input file is our OctoPi stretch image. Stretch is the version of Debian. Okay. So, sorry. Do that again. DD. Block size 4 megabytes. Input file that. Output file is the physical device SDG. And I'm not sure what the conv equals fsync. I believe that's just to keep everything in sync. You can look that up. You look that up in the manual page. Anyhow, let's get that happening. I am not allowed to do that. This is where we get dangerous. I have to get on as the administrator. So here we go. Sudo, which becomes the administrator for that 5 seconds. So this command is being run as the administrator. So it is important that I have this destination correct, because I can actually overwrite any hard drive anywhere. Okay. So it's doing that, and we don't have much confirmation. So you can use a tool called dstat and -d is device, SDG is the physical piece of hardware. Oh, I haven't installed it here, so let's install that while it's happening. Sudo apt install dstat. So it's being installed for me. I'm still setting up this computer, so forgive me for that. Okay, so dstat, I just pressed up arrow twice to get the old command. Now you can see here a rolling report. I might just reduce the size of that window a little bit and put it in a different spot. Now, what you see here is a whole lot of information about wait states and how much work the machine is doing, etc. But what we're interested in is the writing to this device. Now this, I'll wait for it to give the header. There we go. So that's reading and writing from disk SDG. It's writing 13 megabytes a second to that SD card device. That's about as fast as the thing will write. So they might have a read speed of 30 megabytes a second or whatever, but the write speed's a fair bit slower. Actually, I think these are 60 megabytes read speed, but the write speed's quite a bit slower. So you just got to give it the time that it takes. You'll see this drop down to a lower figure than 0 when the job's done, and you'll also see this over here be complete. Funny enough, Linux is actually quicker at copying, but the reporting is limited with DD command. And if I use a graphical interface to copy stuff, it doesn't report accurately for times. That's one annoyance with SD cards. And we simply have to wait till that's done. And let's go back to our website while we're looking at that. Okay, so that was the instruction on that website, what that all meant. Okay, right. So once that's been done, I found with what I was doing, because I'm using the network interface rather than the wireless. Oh, here we go. That's done. You can see it's stopped writing, and it's completed. Okay, so I'm going to eject that disk and reinsert it. Okay, now what we have is two partitions have turned up. So remember how SDG had one partition? It's now got two partitions. One of them, let's bring that to the fore, is the boot partition, and then there's the root file system. Now, what we'll find if we go to our disks utility again, let's just open that. It's getting very cluttered here. Let's go to another screen. Let's open, where are we? Disks. Okay, so let's have a look at our 16 gigabyte disk, and now you can actually see there's four partitions. Before there was one. But what's interesting about the way they've set up the OctoPi, this is free space. And we have also a 4.2 megabyte free space, which is basically nothing. 4.2 megabytes, scarcely a photo in size. Then we've got 45 megabytes, which is the boot partition, and that's done in the FAT file system, which is similar to, well, you know, your DOS file system. The root file system on this is ext4, which is a generalized Linux file system, and then it's got free space. So all you need to have is like an 8 gigabyte SD card to fit all this stuff on. Actually, even 4 gigabyte this SD card to fit it on. And then whatever you've got free, you just leave that. Don't worry about it. You don't need to format it or anything. When we first boot the Raspberry, it actually will grow this file system to fill it out. So this is basically done and ready to be put into the Raspberry. Right, so I'm going to go back to another screen where we've got the other, okay, a big cluttered one. I'm going to just eject the disk now. Okay, so here are the components really of the Raspberry Pi. There's another couple of bits we need. I'll also need a power supply. Now I bought these dual port ones. I'll just open them up. Okay, this is dual port. Total of 3.4 amp delivery. Now, thankfully there's a motorcycle. Okay, so 3.4 amp delivery, but can I focus that any better? Not really, that's about it. Okay, so the bottom one gives 2.4 amps, the bottom one, the top one gives 1 amp. Now the 1 amp is ample for the Raspberry. And of course you need a connecting cable, which has the necessary connector. They come, well, these cases are available. You can use them naked. And what also came with, for some reason, some of them come with these heat sinks, and some of them don't. Now, I've gone for putting the heat sinks on. The first Raspberry I got did not come with these heat sinks. But I figure if any of them come with heat sinks, you should put a heat sink on all of them. So I'm going to get, there's really only 2 chips that I can see on this side that require a heatsink. The other side doesn't have enough space in the enclosure for a heatsink. There are 3 heatsinks supplied, but I can only apply 2 of them. So I'll just put this one on. There's one in place. And there's a larger heatsink for the, what I think is the CPU. Be logical that it is. Okay, so there's the heatsink in place. Now the cases are actually pretty simple to open up. I mean, everything just pops open. Pop the lid off. You need to take the sides off though, they're a little bit hard to take off. So you can pop the case open. There's some tabs on the side here you press. Okay, so you have to put the Raspberry into its position first before you put the SD card in. Don't make the mistake of doing it later. Alright, so I've got 2 heat sinks on, I've got the thing in the case. The next thing we can do is put the top on.
If you want to use the Raspberry camera, you actually have to take, there's like a little cover tape on here and insert it in that location. Alternatively, you can just use a webcam on these USB ports. And of course you've got the network cable. Now for the purpose of the exercise, I won't be using the camera on this guy, but I will be putting out a little operating system disk on there. Insert that from the outside. Okay, so there's a couple of indicator lights. I'll probably can turn it in such a way you can see the indicator lights operating. So I'll get myself this plugged in. The Raspberry Pi is so light in weight that the cables just pull it around everywhere. Okay, what I might do is actually hook up the HDMI to this monitor. To my intention. Okay, you can see the cables just lift the unit up. Alright, now I'm going to try and catch everything happening all at once. Okay, it's booting up. I don't know whether you can see that, but I'll try and... It's resized the file system, that's what just happened. Okay, so that happened. You don't need a monitor on your Raspberry to have this happen. But basically it's alive and well. I can hook up a keyboard to it with my little USB device here, receiver. That'd be good. So there's very little weight in that unit. It's like handling a, I don't know. It's lighter than a mobile phone because you don't even have a battery. Alright, so you can log in it and use it as a command line tool from here. And let's see if I can zoom in enough for you to see the detail that's on that screen. Now what it tells you when you are logged in here, focus, about my limit there. Okay, what it says here is that here's the IP address of this unit, here, it's 192.168.1.159, and it is also identified as OctoPi.local. Underway now. So that's basically what it would look like if you plug a screen into it. We can log in here. I will do it just so you can see that it happens. Username Pi, password Raspberry. Okay, so we've actually got a command line interface here. Funny enough, we should be able to do LSBLK here. And you can see the block files. Now it's called something different on this machine because it's arranged differently to a PC. But basically that system is up and running. We don't need to have done any of this because we can do that from the host computer. But I will actually just go back to the host computer.
Okay. So get a password. Again. So enable that, yes. Next. All right. Next. Okay. This is new on this version, so this is already an upgrade on what I had before. I'm going to skip the blacklist I'm actually well behind a firewall. It's very hard for access from the outside world. Anyhow, next. Now you can actually get the Raspberry to process using a Cura slicing engine, but you need to be able to import an INI file, and so far I haven't been able to successfully do that because the current version of Cura is too new. So you have to get an earlier version of Cura, install it on your PC, set up whatever your profile has to be, and then save it as a profile that you can now import to this engine. That's if you want to do the slicing on the Raspberry. You may or may not choose to do that. The advantage of having the slicing done on the Raspberry is, of course, you can do designs from whatever number of computers you've got around the place, send them a slicing job, send the Raspberry a slicing job, and let it do the slicing for you. Disadvantage is the Raspberry hasn't got the processing power that your computer would have, and so if you've got heavy slicing to do, maybe better off to do that on your PC anyway. So I'm a bit mixed about this one, which way I want to go. But in any case, the next thing we have to do is we have to set up the printer profile. We have to give the kit a name. Now this one's going to be my first Delta, so I'm just going to call it Delta. That sounds about right. Print bed and volume, center. It's circular. I'll call it 170. Axes, that's fine. Hot-ended extruder. I pretty much settled on most of my printers to 0.6. Some of them I've got a 0.4, but most of them are 0.6. Next, so I've set it up for my Delta. There's some warnings. So that is our OctoPi rig set up. I need to actually physically connect it to a printer. But what I've actually done is I prepared one earlier, and it's already got a camera on it. But there's a couple of things I'd like to do on this nonetheless. Now, it was that location was the IP address of the unit was 192.168.159, right? Or it's known as octopi.local. Now that's its generic name when you first install it. Now, of course, because I'm installing 5 of these things, I want to have a different name for each one. Now let's just go to another screen and close a few windows, just for me, not for the computer. The computer's fine. Now I'm going to do that fresh. We'll open a terminal. That'll do. Okay, so we can use what's called SSH, and the username to access is Pi. The device is currently called OctoPi.local. Now, I previously logged into another one installed, and I have to remove my SSH settings for it. Okay, so let's do that again. Just press the up arrow, it gives me keyboard history. Okay, now we can approve it. Yep. Its password is Raspberry. Okay, so now we're logged on to, it's the same as being on the other screen that you saw with the monitor plugged in. So this is why I say you don't actually need a monitor, keyboard and mouse plugged into the Raspberry, because we can access it via SSH and we can access it via the web interface. So now we're actually on as a user registered within the system on the Raspberry. Let's get on as administrator. And we have to type the password again. Now you might remember I used sudo to get the dd command happening under Linux. Well, we use the same command to get on as administrator. Sudo gives us super user privileges, and SU is actually to run a super user environment. So you can see now my username is root at the machine called OctoPi, and I'm at the user's home, home pi. But now I like a program for working in an SSH environment called Midnight Commander. MC is the command, and it's not found. So let's install it. So I'm on the Raspberry, it's connected to the internet, so apt install MC. So it's going to check its list of goodies to see what's available to download. And all the Linux distributions have got basically this kind of thing available to them. So knowing your way around a Linux distribution is an advantage, so I'd recommend get it like Ubuntu made or something. It's good for new users to find their way around and have a bit of a play and get to understand how the system works. This is not essential what I'm doing. You can actually access it from the SD card, but I just want to show how you can administer the Raspberry from within. Okay, so Midnight Commander, I'll now run, and you can see I've got two text windows, sort of the main window split in half. Okay, so we on a Linux system, actually as far as I know all the Unixes, you've got a file tree like this. Now all the settings pretty much for the system are kept in the etc directory, and what we're after right now is the host name. So I'm going to edit the host name, and I'm going to use the third option, MC edit. Okay, it's currently called OctoPi. We'll change it to Delta. Save it. On the bottom of the screen here, you can see 1, 2, 3, yada yada. They equate to your function keys. Like F10 is to quit. Let's do that. F10. Let's save it. Now I'll get out of Midnight Commander. Tell it to reboot. So the Raspberry's rebooting. So if I try to use SSH to octopi.local, it won't find it. But if I go delta.local, it should find it. RASPBERRY. Okay, so now I'm at the device called Delta. But if I go up arrow, you'll see my history of things. As the user Pi, I type those two commands in. Okay, now df is the command for disk free, and you can see that's how the file system is arranged. And I won't go any further into that, but basically you can see I'm operating that thing as someone logged into the real machine on the user. You can see I'm really logged in as a user on the Raspberry. The unit's been renamed to Delta. So that's how I renamed the Raspberry to suit my different printers. Okay, so let's go to the web browser and see what that looks like now. Now it won't be able to connect to octopi.local, so I'll just change that to delta.local. DELTA. Wait for it. There we go, we're up. Okay, I want to save that so this remembers. Basically now I'm on as the administrator. I've got some really nice tools in this interface. This control gives you the webcam. Then you can see there's my round print table. Then you can see also any commands that are sent to the printer, and you've got the ability to control a time lapse. Now because there's no camera on this unit, we'll have to leave that alone. I'm going to open up another unit, and I've got it called Prusa. So Prusa.local. So you can see I've got delta.local and prusa.local, but prusa.local's got a camera on it. So you can see inside the printer unit, we can see the temperature that's running at. I'm not sure we're connected, we're not, so I'll just get that turned on. Okay, so let's connect to it. It's alive. Okay, so we can, this is a file I sent it before. We can quickly upload another file. So if we go upload, scratch around, I don't know, knob.gcode, there we go. Open. Now I can pick knob.gcode and go print. Now you can see here the desired temperature is specified here for the print table, and you can see now the temperature of the print table is actually increasing, or flattened, whatever you want to call it. We can see not much is happening in the unit at the moment, so let's go back to our temperature. Now we can of course open this in a new tab. We can break the tab out, put that unit to the right, to the left, so we can see in two windows we can see the temperature rising and we can see the camera. And my hope is everything will print right, but knowing how things go, it may well play up. Alright, so the temperature of the bed is heating nicely. So we could potentially, as you can see, I've got two windows open here. One's showing the temperature, how it's running, or I can, I can switch different. We can even look at the video camera from there. So I can switch to different. And there's the terminal, what's being sent and received. I've got it set to do time lapses. We have got a time lapse. This one looks very interesting. Let's download that one while we're waiting. Yeah, let's save the file for starters. I don't know where that went. I've not done this before. There we go. Let's see what that time lapse was. Probably pretty lousy. Yeah, because the camera angles are very bad perspective. Whoop, it's up and running. I can hear the printer working. Let's see what it's doing. It's doing a home cycle. See how temperature's going. The bed's reached its temperature. Now the hot end has now been lifted in temperature. Well, it's heading for the desired temperature, which is, what is it meant to be? 220. Okay. So it's heading for 220. And while it's doing all of this, we're able to download the time lapses from before, but it's actually doing a time lapse at the moment with the webcam. It takes one shot each layer. Now what I'd like to do is get a webcam actually physically fixed to the print bed so that the camera is static according to the print job. With the Delta I'll automatically have that because the Delta's print bed doesn't move, only the head does. So I'll probably end up putting this camera on the Delta and getting a webcam with a longer USB cable for the table. Anyhow, waiting. I'm a big fan of Slicer. I've been trying to get my head into how Cura works. There's quite a few things I like about Cura, but there's a few things that it doesn't seem to have that Slicer's got. I find Slicer's got the settings more available. Cura, you've got to sort of enable them, which is not a bad approach either. I'm not sort of putting one down over the other. But I've gotten very familiar with the expert mode on Slicer. It gives me a lot of controls. And it's interesting to watch the temperature gradient as the controller rethinks. Okay, I'm expecting it to probably start doing a little dance now and get on with printing. We can see what's being sent to it. Yep, it's busy. Temperature. Not really quite sure what it's been a while since I've done this part, so I don't know what it looks like exactly. But anyhow, you can see it's printing away, doing its job nicely. And so by giving each one a different name, you have, in this case it's the prusa.local, delta.local, so whatever you make that hostname file represent, that's what gives you your different printers. So I'm hoping that I can, with all these printers set up, once everything's all going, to give me the ability to handle whatever number of printers just by giving them a different name. And of course I've got to get it all connected. So I hope you've enjoyed that video. Feel free to like, share, subscribe, ask a question, leave a comment. Bye for now.